Welcome in friends to our YouTube channel Weirdoss. In this video tutorial we'll be studying about sodium and potassium pump and how actually it works. So let's get started. So this is sodium and potassium pump. It is normally said as it's active transport mechanism. It is normally also said as a sodium potassium ATPase pump or sodium potassium exchange pump. Why exchange pump? Because sodium and potassium this is a transmembrane. Okay, in transmembrane. Why? Because it changes its structure, protein conformation. So sodium and potassium pump, the sodium and potassium they pump in opposite direction. So it's also known as active transport mechanism and sodium potassium ATPase pump. So we'll be first we'll try to understand how does it function in basically very three steps. So first, this is our membrane. Okay, we all know about our transmembrane, and this is a protein. So it's a transmembrane protein. So in resting state, this protein has affinity towards the sodium ions. In resting state, this protein has affinity towards the sodium ions. So what happens? Sodium ions they get influx from inside the cell towards this protein. So 3 sodium ion they get bind to the protein, and as soon as they get bind to the protein, ATP comes into picture. ATP comes into picture and ATP gets hydrolyzed into ADP and phosphate group. This phosphate group it phosphorylates these sodium ions. This phosphate group it phosphorylates these sodium ions, leading to conformational changes in protein. So basically प्रोटीन ऐसा था, अब प्रोटीन क्या हुआ, जैसे फॉस्फोराइड होता है प्रोटीन, it changes its conformation and opens towards outside. First it was opening towards inside, now it is opening towards outside. Then this is the first step. Then in second step the sodium, then there is a change in the conformation of the protein, but this also leads to release in energy, release of energy, and this release of energy that leads to the conformational change in protein, and the protein gets open towards outside. And then as soon as there is a change in conformation of the proteins, it no longer has affinity towards the sodium ions. अभी इसको सोडियम आयंस की तरफ उसकी अफिनिटी नहीं है, तो क्या करेगा, वो रिलीज कर देगा सोडियम आयंस को. सोडियम आयंस को जैसे वो रिलीज करेगा यहाँ पे, सो हमारा जो बेसिकली जो काम था कि सेल के अंदर से सोडियम टुवर्ड्स आउटसाइड, वो रिलीज हो गया. अब क्या होगा, उसकी उसकी अफिनिटी टुवर्ड्स पोटेशियम बढ़ेगी. So potassium ions will come. So here potassium will bind, and again ATP will come in this picture, and it will dephosphorylate. Why it will dephosphorylate? Because it already has phosphorylate in the first step, resting membrane state, when it has affinity towards the sodium ion. So again from outside, सी बेसिकली ये सेल के अंदर की सेल के मेम्ब्रेन के बारे में बात चालू है, तो यहाँ पे क्या हो रहा है कि सोडियम अंदर से बाहर की तरफ जा रहा है और यहाँ पे पोटेशियम बाहर से अंदर की तरफ आ रहा है. सो पोटेशियम विल कम फ्रॉम आउटसाइड एंड इट विल बाइंड टू द protein, and again there will ATP will come into picture. It will dephosphorylate the protein and it revert back to its original conformation. Original conformation क्या था, ये था. Back to the first picture. Okay, then again it will release the to potassium ion, and in every cycle there is 3 sodium ions releasing outside and 2 potassium ions, there is an influx of the 2 potassium ion inside. So this is basically how does the sodium potassium ion function. So we will first start with our explanation कि sodium and potassium they pumps in opposite direction. At resting state it has affinity towards the sodium ions. Then 3 Na ions they bind to the pump. It is phosphorated by the ATP. There is a hydrolysis of the ATP into the ADP and phosphate. Then the phosphorylation is done. This leads to release of the small amount of the energy, which leads to the change in protein conformation. Change in protein conformation. Then as the protein conformation changes, it opens towards the outside and it releases the sodium ions, and then it has affinity, its affinity changes, it no longer has affinity towards the sodium ions. So then the affinity of the potassium ion increases, and the potassium ion binds to the protein. Again ATP comes into picture and it dephosphorylates it. After the dephosphorylation, there is again releasing they change into protein conformation, but in this case it come backs, it reverts back, it regain its original conformation. So these proteins are kind of the fascinating machines. All these are regulated by the proteins. Okay, then there is a change in the original conformation. Okay, so for every cycle there is a 3 sodium ion releasing outside and 2 potassium ions are releasing inside. So basically ये कहाँ पे होता है मीन्स एक बेसिक आइडिया हम लोग लेंगे कि ये किस तरह से फंक्शन करता है. सो वी नो दैट सोडियम एंड पोटेशियम आयन का it is related to nerve impulse. It has various kind of a function and various cellular machinery, but हम लोग एक बेसिक आइडिया लेते हैं to get a better understanding. For example, this is a nerve. It is an axon. This is outside of the cell, this is the inside of the cell. We know कि in the axon, in the nerve cells, we have the voltage gated channels. So we have different voltage gated channels. So I'll be listing here the voltage gated channel. So this is the voltage gated channel for the sodium and this is for the potassium. We know कि we have released the sodium outside of the cell. So यहाँ पे there would be the sodium concentration would be more, and in this side the potassium concentration would be there. So what happens as soon as there is a nerve impulse? What happens? The due to the concentration in due to the increase in the concentration, there is a diffusion gradient. This is known as a diffusion gradient. Due to the diffusion gradient, there is an influx of the sodium ions. There is an influx of the sodium ion, and the simultaneously there is a efflux, or you can say releasing of the potassium towards outside. And due to this, it leads to the you can say nerve impulse, then uh, calcium ion concentration. We know that there is a calcium ion concentration, uh, the release of the calcium ion, which leads to release of the neurotransmitter, neurotransmitter and then the neurotransmitter, it attacks and it goes to the, and it leads to the various kind of the changes in the cellular machinery, because it directly affects, it directly go to the target cell, leading to the cellular changes, leading to the cellular changes. So this is how it functions. So after that, see, there was sodium ion concentration more outside and potassium ion concentration inside the cell. This is out and inside. Here sodium ion, how it came? Because of our sodium potassium bond. यहाँ पे पोटेशियम कैसा है? Because हम लोगों ने बाहर से पोटेशियम अंदर की तरफ किया. अभी वापस जैसे ये हो गया, नर्व इंपल्स हो गया पूरी तरह से, फिर क्या होगा? वापस ये प्रोसेस स्टार्ट होगा. वापस क्या होगा? सोडियम अंदर से आएगा, then potassium will come from outside, and this process will be get on repeating. This active transport mechanism is done by the sodium potassium pump. So uh, quite interesting example. Mostly the when you visit your dentist, he gives a he provides you with the lidocaine. Lidocaine, it what it actually does, it blocks, it blocks this it blocks this sodium ion channel, this voltage gated sodium channel. We know that sodium, it has a great function in the nerve impulse, leading to the conformational change, leading to the various kind of the cellular machinery in a signal transductions. Okay, so it blocks, there is a blocking, and due to which the sodium cannot go further inside the voltage gated channel. So the whole process stop, and due to which we don't feel the pain. So this is a quite interesting example of the sodium potassium pump. This is how the sodium potassium pump regulates and it works inside our body. So these are the steps, so you will not get confused. Resting state, opposite direction, affinity for sodium ions, then conformational changes, then fourth. Same procedure is repeated, but here it does not get phosphorylated, it is dephosphorylation, because phosphorylation already हो चुका है. Then change in original configuration every cycle. 3 sodium बाहर जाता है, 2 potassium अंदर जाता है. So hope this helps you. Thank you.